Okay, here I'm going to go through and explain a practical on oscillations. It's going to make use of a mass on the end of a spring. There's a spring just slightly above this, and that means that when I depress it there, you can just see the spring coming into sight. When I release it, it will start to oscillate. I then have a motion sensor below that's sending off an ultrasonic pulse up to the top and back down again. It's telling me from the time it takes for that pulse to get there and back how far away that mass on a spring is. And I've just got this bit of paper around here so we can easily reflect better. Now if I depress and collect the data on my computer screen here, I've got a nice graph showing you the position against the time. So where this is positioned above and below the motion sensor with respect to time. And if I keep collecting, you can see that the amplitude of the oscillation is decreasing, but the time period stays the same. And what we're going to look at is we're going to look at the time period of the oscillation. So let me just stop that there. Start this up again. I'll just take a few time periods and expand them. Brilliant. So the time period, so how do we measure the time period again? The time period is one full oscillation that's occurred. And so therefore we usually take the peak and we look at the time difference between those two. There's another time difference, there's another period of the oscillation, there's another time period there. We could go trough to trough if we wanted, or even from a middle point to a middle point, but it's much harder to read. Time period is the smallest repeating unit on that graph. Okay, now the way in which we're going to do this is we're going to move the cursor to the tip of the oscillation, to the peak, and we're going to have a look at the coordinates which are fed out in the bottom corner here, which are tricky to see, but that's 0.894 of a second. I'll transfer that to our graph. So what are we going to investigate here? We are interested in looking at how the mass, changing the mass, affects the period of the oscillation. If I'm changing it, this is going to be my independent variable, and if I'm measuring, this is going to be my dependent variable. Mass is going to be measured in grams, the time period is going to be measured in seconds, but of course there's no point taking just one time period. We want to make this as accurate as possible. So what we're going to do is we are going to take, let me try and draw that trace. We're going to take the time period here, the time period there, the time period there, and then we're going to measure the difference here, which is a time period. We're going to measure the difference here, which is a time period, and then we're going to average those two out to get the time period. Okay, that's the rationale. Changing the masses, we're looking at the time periods and how it will change and affect. So let's get a table of results. Everything that I change, my independent should be on the left. So let's get down the mass in grams. Units are important. I'll then take the time period of the first peak. So the time in seconds of the first peak, the second peak, and the third peak. We're then looking to get the period between those two, so the differences, the periods, should I say, of the first and the second, and then from there I want the average, or should I just say the time period in seconds. And then finally what I'll do is I'll work out the frequency in hertz. So there's a lot to do there. Let me just draw in my table. My time periods. And of course my mass. This is good so far. I'm going to be looking for my first time period, second time period, before I finally take averages of them and then work out the frequency last of all. Okay, let's get a few sets of results. And first, quick result and see what happens. I'm on 300 grams. The instruction asks me to start from 300, though I will go from 100. I don't need the G in there. 200, 300, 400, and finally 500, but I'm starting with the 300. So, depress it slightly, and I'll collect. That's good enough. Auto range it. So let's take the first peak. The very peak of it, of course, I'm looking for. That's going to be 0.72. The next one is 1.45. And the next one is 2.14. Okay. In order to work out the first time period, I'm just subtracting this one from that one. Remember, I'm looking for this time period here, so I'm going to subtract that from that, which gives me fairly easily 1.45 minus 0.72, giving me 0.73. The next time period will be subtracting this one from that one, 2.14 minus 1.45, 0.69. I average them together and by adding them and dividing by 2, because I have 2 readings, give me 0.71. Just remind you that average equals, let's call this one period 1 and period 2. Period 1 plus period 2 over 2, because I've got 2 readings, which I've done successfully here. And then finally, the frequency is 1 over the time period. And that's measured in hertz. So if I have 0.71 as my time period, 1 over 0.71 gives me 1.41. 1.41. Okay, so then what happens? Well, I've got that row of results. Now I'm going to look for the 200, 100, 400, 500. So if I were to add an extra mass onto here, 100 gram mass. Now I have 1, 2, 3, 4. If I start to move that, you can see that the time period has decreased. And I'm going to collect the results again, and I'll come back when that's done. Okay, so here are the results finally that I've collected. I hope you can see all of them on the page there. It's probably worth mentioning that when we have a much smaller mass, as you can see there, just one of them, this starts to bounce around all over the place and it becomes much harder to measure it. Also, with the greater amounts, you need to raise the retort stand up because obviously the spring will stretch more. So a few little tweaks required there. But essentially what we're saying is as the mass increases, so that was our independent variable, the time period increases, which is what we saw. And because frequency is inverse, the frequency, the number of oscillations per second, it's much more with less mass because it has a smaller time period than with more mass that has a longer time period. So the frequency decreases as the mass increases the time period increases as the mass increases.